prominences? Because some people's eyes have trouble seeing them. It's okay. If you have real light-colored eyes like mine, it's kind of difficult to see them. So, who can tell me how far away the sun is again in miles after you raise your hand? Shh. I can't see unless you raise your hand.
What?
How many miles away is the sun? Yes, ma'am?
93 million.
That's right. Here you go. Here's a cheap yet thoughtful bookmark. Okay. Now, who knows what the speed of light is in miles per second? Anybody?
Oh, wait, no. Me? Alright.
Okay, who knows what the speed of light is in miles per second? Raise your hand. Oh, we got one over here. Were you in the last class?
Yeah.
Okay, you can't.
186,000 miles per second.
That's right, 186,000 miles per
I never heard
second.
it.
Okay, so if you turn a flashlight on right now and it was bright enough to shine around the world, it would go around the world 7 times in 1 second. 1. So I turn it on. 1. It's already been around 7 times. Okay. Knowing that, and the sun is 93 million miles away, how many seconds do you think it would take it for the light to get from the sun to our eyes? So you divide 93 million by 186,000.
8 minutes. 20 seconds.
How many seconds do you think it would take if you weren't in the last class?
Oh, 400.
About 500 seconds. Okay? 500 seconds or so for the light to get there to here. Now that's 8.5 minutes. Okay? So what that means is, what? Okay, what that means is the light that left the sun doesn't get here for 8.5 minutes. So when you look at the sun, you're not really looking at the sun, you're looking at the light that came from the sun. Okay? So it takes about 8.5 minutes to get here. Now, it's a little warm right now and getting warmer, right? Because we're going into summertime. Does anybody know if the sun is closer or farther away in the winter, in the summertime? Is it closer or farther? Raise your hand. It is farther away. You're right. So even though it's getting warmer, you pass that back. Even though it's getting warmer, the planet Earth is actually farther away from the sun by about 500,000 miles. Okay, so it goes between 92 and 92.9 million miles because we orbit in an ellipse, right? Not in a circle. The reason it's warmer. Did anybody know why it's warmer in the summer? Because the Earth is tilted. Is that what you're going to say? Well, that's why, because the Earth's tilted. In the summertime, the Earth is tilted, whereas the northern hemisphere that we live in is tilted closer to the sun. So we get more direct rays instead of bouncing rays. Okay? So that's why it's warmer. Now, in Brazil or in South America, in Australia, in the southern hemisphere, when it's warm here, is it warm down there too?
No.
It's wintertime in South America, right? Yeah. So that's why, because the Earth is tilted away for the southern hemisphere. So that's how the seasons work. Even though we're closer in the winter, we're colder because we're tilted away. Now, does anything else emit light around here that's natural? Or does things reflect light?
Just like light.
Yeah, the only thing around us that's naturally emitting light is the sun. So that means every bit of the light you're seeing right now came from the sun. And it's bouncing off stuff, and that's why you're seeing it. So like this brick wall right here, the only reason we're seeing it is because sunlight is coming down and bouncing off different things in the environment, bouncing off that brick wall and going to your eyes. That's why you see me too. Now I know I'm quite handsome, but try to look at me for just a second. When you look at my face, this light came from the sun, bounced off my face into your eyes. Okay, does everybody get that? Now, I got a question now. If it takes 8.5 minutes to get here from the sun, to get to my face, to bounce off, how long does it take to get from my face to your eyes?
0.00000.
About, very short time, right?
Yeah.
Very, very fast. So what that means, what I want you to understand though, is it does take some time to get from my face to your eye. Okay, it's not instantaneous. So if you put all this together, you start talking about the theory of relativity that Einstein wrote in the early 1900s. It takes a little time. So you're not seeing me right now. Even though you're looking at me, you think you're seeing me right now. My now is not the same as your now. Okay? You're seeing me a fraction of a second ago. So everybody always asks, well, what if the sun blew up? Will we know about it? Yeah, you'd find out about it in about 8 minutes. About 8 minutes later, 8.5 minutes later, you'd see the light from the explosion. But by that time, we'd all be dead anyway. But what if I blew up right now? Okay? What, would you see it? You'd see it a fraction of a second later. So I may have already blown up and you don't even know it. Okay? That's how light works. Light is not instant. Light takes time to travel. Okay. Now, if I'm standing this close to you, then you can see me a little bit closer to present. Right? If I go back here and stand way back here, you're seeing me a little bit further in the past than you did up close. So, you know, they say you can't travel back in time, which is true. We can't physically travel back in time, but we can see back in time everywhere you look. So if I'm looking at the constellations at night, you know, the stars and things, there's plenty of stars out there that are hundreds of millions of light years away. And a light year is the distance it takes light to travel in 1 year, which is a long way, 6 trillion miles. Okay? So if you're looking at a star that's 100 million light years away, how long ago are you seeing that star? 100 million years? That's right. Because that's how long it took for the light to get here, 100 million years. Now, let's say you were on that planet rotating around that star on their version of Earth, and you had some Mac Daddy telescopes like these and a gangster ride, and you were pointing your telescope at us, and you could see us, and you were on that planet that's 100 million light years away. The sunlight will reflect off the Earth, go to that planet. You see the moon right there, the half moon? The only reason you even see that is because sunlight's reflecting off of it and coming to your eyes. Okay? But anyway, if you were on that star or that planet 100 million light years away, looking at us right now, and you could see us right now, what would you see right here? Anybody know?
Dinosaurs.
Dinosaurs is right. You'd see what the light that left here 100 million years ago and is just getting to that star now. Okay? So can you go back in time? No. Can you see back in time? Everywhere you look, you're seeing back in time. Okay? Yeah, it is kind of weird, isn't it? Yeah. Now, Einstein says the faster you run or the faster you travel, the slower your time goes. And that's a long story. We won't get into that this time. But it's a very simple theory if you start to study. But that's what relativity means. It means if I'm going at the speed of light, then my version of time or what's present is not the same as somebody who's standing still. Okay? And it's all very simple, but when you get into that, you'll understand. Now, anybody here want to go to Mars when they grow up? Anybody want to be an astronaut with NASA? They don't pay much, but it's a good job. So, somebody from this class, how old are you guys? 13, 14? Somebody from this age group is going to be on the Mars mission that's going to come in 10 or 15 years because they already got all the planning going. So, if anybody wants to go there, there's really no reason why you can't. If you weren't in the last class, do you know the difference between you and a shuttle astronaut right now?
Nothing.
They're in space.
Can you tell me the difference?
In space.
Nothing. That's right, there is no difference. They're a little bit older than you, that's it. So, I mean, somebody's got to do it. It might as well be you, right? All you got to do is pay a little attention in class and, you know, look at the people that are doing it now. They're no smarter than you are. They just been to a little bit more school. So that's about it. Mr. Kumo likes for me to tell you how I came around, or you want to talk about that, or?
Well,